I'm Quentin Allen, and I'm the previous operations manager here at Kansas State University from October 2010 to July 2012. Today I'll be taking you through the cleaning house startup and some of its operations principles. So sit back and enjoy the ride. First thing we're going to do is select the paper icon there on the right hand side of the screen to open up the job overview. We're going to select New. And we're going to begin filling out the job window here from the top down. We'll start with the product identity, which is usually hard red winter, but it is whatever type of wheat you're tempering for the day. So you pull that down and select it from the drop down menu. Next we'll move down into the first box, which is the target weight. I would recommend overshooting your target weight by about 500 pounds just to ensure that you get to your target. The discrepancy in this could be due to flow balancer error and that type of thing. So 500 pounds over your actual target. We run the mill at 2,205 pounds an hour, so you can do your calculations from there to determine your target weight based on the run length request of any given instructor and or other Kansas State personnel. Next, what we'll edit is the bin flow rate. We're going to set that at 6,000 pounds per hour, and we're going to keep it there. The cleaning house runs best when it's loaded up fully. So the combi cleaner, for example, will not function correctly if the load is much less than 6,000 pounds per hour. Next is the dry filling time. It's defaulted at 0, and I would recommend leaving it there. We typically don't use a dry filling time. It takes enough time for tempered wheat to actually make it to the mill out of second cleaning that we don't want to really increase that, but why it's there is just to prevent chokes in the bottom of the pre-temper bin. Moving up and to the right, we'll talk about the target moisture. Usually for hard red winter wheat, that's going to be 16 to 16 and a half. At the Hal Ross mill, I wouldn't recommend going much above 16. For soft red winter at Hal Ross mill, 14 seems to be pretty good. I wouldn't go much higher than that as the product tends to get a little bit sticky at times. Next we'll move to the moisture offset. A good target for that is negative 0.4. What that means is that the moisture analyzer upstairs on the fifth floor is just that much offset from the actual value. So I would recommend taking a sample of the dry wheat and running it on the Unity machine during your run and adjusting this accordingly. What it does, it'll bring the actual moisture in line with what the actual moisture shown on a Unity or other measurement device tells. As far as the max water flow rate, I tend to put this at 165. It's usually a good measurement for wheat that's not very, very dry. And when it tends to get dry enough that you're putting that much water on, you probably want to do a two-stage temper anyway. There is a calibration chart available in the Hal Ross Mill FAQ manual, so you can see the calibration curve for the MyFC moisture analyzer unit. If we move directly to the right, we can see that there's a checkbox that says use indent cylinder. We always want to make sure that that's checked. That's the equipment that we tend to use most of the time. You can use the Carter disc separator in the event that someone wants to demonstrate its capabilities, but I tend to use the indent cylinder more often than not. Moving to the cinders section of the window, I personally take and try to empty one R bin at a time. It's not really advantageous to blend these bins as they all come from one lot. In a normal commercial setting, you would want to blend your raw wheat bins as much as possible to get the best blend of wheat on the mill. It's not really concerning since we have basically one truck load fills up all 5 bins. After making your R bin selection, you'll want your receivers to be selected. What I usually do is I either fill T1, 3, and 5, or I fill T2, 4, and 6. This is mainly on efficiency purposes so that when you're opening up the bottom of the T-bins before you mill, you only have to walk on one side of the flow balancers. And that's the way I roll. From there, I put a remark into the comments field, basically to ensure traceability. Basically, what is the run for? Who are we doing it for? What class? What short course? And from there, we can save the job, and we can either close that window, go check everything else out, or we can check the job, at which point it'll tell us if there's an error or not. And if there's no error, we can hit man start job, MAN start job, manually start the job. And that will start the mill, the cleaning house sequencing up. Now we're just going to give you a little bit of time so you can see me actually fill out these parameters. As you can see, they are the same as what I indicated to you just a minute ago. And now you can see me check the job, manually start the job, and we will begin watching the sequence of the mill starting up. This is the cleaning house section. So I'm going to flip over to plant utilities. I'm going to turn up the makeup air to equalize the plant, usually at about 60% when just the cleaning house is running, depending on the makeup of the roof vents. What will happen now is the aspiration is starting. You can see it's in light blue. It will start up the cleaning house aspiration, the big fan on the 5th floor. Following the aspiration, the screening system will start up. You can see the rotary lock below the screening's scale starts up first, and everything will sequence backwards. That's typical of most systems. The end item in the process will start up first, followed by the next inline, followed by the next inline, all the way until you reach the front of the process. You want where your product is going to start up first, where it is coming from to start up last. We'll be able to see that with the wheat transport and the entire cleaning house here in just a moment. Now we flip over to the first cleaning screen. The raw wheat scale is being filled right now. Now this is its own separate subsystem, so it is started first, the blower, then the airlock, then the screw conveyor beneath the R-bins, and then the flow balancer. Now what we're waiting for now is for the low level to be covered on the raw wheat scale. You see it's blue right now. It will then turn to white once it's covered, and the rest of the cleaning system will start up. While we're speaking about low levels, high levels are white when they're uncovered and red when they're covered. Same goes for blow lines. The pressure indicator will be blue when there is no product flowing, white when there is an adequate amount or operational amount of product going through the line, and red when there is high pressure or too much product going through the line. We've fast forwarded to where the low level is now covered on the raw wheat scale. You can see that it's white. You can see that the wheat cleaning system is starting up. Aside from auxiliary systems such as aspiration, the wheat cleaning system will begin to sequence up from the last item in the flow to the first item in the flow. So we should see the turbolizer kick on here. There it is. We're running off the same blow line, so it's already started up. We've got product transfer going. There is the airlock below the indent and the combi cleaner. The indent cylinder is starting up from the bottom to the top. And now the combi cleaner. And then we start product flow. One of the things that I do some of the time is I actually stop the product flow by putting it in manual, just to give the raw wheat scale a little bit of time to fill up so it stays ahead of the system. I plan on trying to get this programming change fixed, but for the current time, it works if you just let the raw wheat scale fill up for a short amount of time, anywhere from 5 to 10 minutes should be fine. Go ahead and auto the line now. And we flip over to make sure the air compressor is still in manual. Don't want it to shut off. And now we can continue the line. Anytime after you take it out of automatic mode, you have to put it back in auto and then continue the line. Once you've continued the line, you can see that it's illuminated there in bold letters. The product lines will turn from orange to green, and the wheat will start flowing through the system, through the combi cleaner, through the end cylinder, blown up to the moisture analyzer where you will start getting a readout. You want to check that readout and match it up with the calibration curve that I've got in the Hal Ross flour mill FAQ manual. You want to make sure that it's pretty well on target and that it's pretty well stable. Most instances that you get a lot of water fluctuation is because of an issue of product flow, and most likely that product flow can be traced back to the combi cleaner. The combi cleaner is not adjusted right. The flow, if the airflow in the combi cleaner is not right, you're going to get product surges through the system. That pretty much sums up the cleaning house startup. I'm going to make a few other operational observations. Basically, as the pre-temper bin is filling, when the low level is covered, then 15 minutes after that, the wheat receiving system will start up. So at the end of every run, you still have 15 minutes of wheat transfer left to go, assuming there's no problems. As for first cleaning, it pretty much does a good job of running itself. The only other small problem you may encounter is if the raw wheat scale does go empty, the scale will actually illuminate in blue and the system will keep filling. You'll see that the low level in the bin is covered. You'll have to click on the scale icon and hit set full for the wheat to start running again. When the targets are reached, the cleaning house will shut itself down. Again, it will shut itself down from the first most piece of equipment to the last most piece of equipment. It shuts down in the opposite order that it starts up in. You shut off the wheat flow first, let it cycle through all the machinery to make sure the machinery is empty, through all the transport lines, through the moisture analyzer unit, finally the pre-temper bin, and into the temper bins. It's that way with most systems. This concludes my footage for the cleaning house startup. Thank you for watching.